Now that we have worked with dividing fractions, we're going to use that in another area that we've studied. We're going to solve equations using division, but this may involve division of fractions. All right, let's go back and review something we've done in the past. We have an equation. It's got a left side and it's got a right side, and I like to put this barrier, and I want this to say x equals, and I look at it and say, well, what's going on between the 5 and the x? When 5 is written right beside x, it means multiplication. The inverse of multiplication is division. So I divide by 5 and I divide by 5. 5 over 5 is 1x, and 15 divided by 5 is 3. The inverse of multiplication is division. That's what we've done in the past. Let's see what we're going to do in these problems. All right, let's take a look at just problem number 1. It says 3/2 times x is equal to 45. Well, remember what we did before. We divided by the number that's multiplied times our variable. So I'm going to take 3/2 x is equal to 45, and I'm going to divide this side by 3 over 2, and I'm going to divide this side by 3 over 2. Now that gives me x. I'm going to take this problem and I'm going to go off to the side, and I'm going to write it a little differently. This is 45 divided by 3/2. Now it looks like a problem we just finished. Put the 45 over 1, and we do keep 45 over 1, change, and flip to 2 over 3. Can I reduce? Well, I don't know if you realize it. Let's look. Remember your divisibility facts. Is 45 divisible by 3? Well, what's 4 plus 5? 9. Is 9 divisible by 3? The answer is yes, so I know 45 is. So I'm going to take 45 and divide it by 3. 3 goes into 4 one time. Subtract, bring down the next number. 3 goes into 15 5 times. 5 times is 15. All right. That means that 3 goes into itself once and 3 goes into 45 15 times. Now, multiply your tops. 15 times 2. You can do that on your paper. It's 30. 1 times 1 is 1. And my final answer is 30. X is 30. Now, all of this work I need to be able to see. I want to be able to refer to this division. All right, let's do another one. I have 8/5 x, 8/5 y is equal to 24/5. All right, 8/5 y, and I don't have to put the dot. It can be what we call implied, is equal to 24/5. All right. 8/5 is being multiplied by y, so I'm going to divide by 8/5. I know that looks a little strange. We're going to change it in just a minute. 8/5 over 8/5, anything over itself is 1, so that's 1y. And now I'm going to go off to the side, and remember that that is 24/5 divided by 8/5. I'm going to do keep, change, flip, keep. 24/5 times 5/8. Keep, change, flip. Can I do some reducing on my diagonals? In other words, can I bow tie? Yes. 5 goes into itself once. 5 goes into itself once. 8 goes into itself once. 8 goes into 24 3 times. 3 times 1 is 3, and 1 times 1 is 1. That gives me the whole number 3. So I'm putting my division over here to the side. because I cannot divide fractions in my head. All right, let's look at another one. Well, it seems frozen. Let me check on it. Well, let me add a couple more problems to, oh, there they are. I don't know where they had gone, but they have come back. All right. All right, I'm going to move this 4964 to where I'm more comfortable with it. Let's look at 49 over 64y is equal to 7 over 16. It is just a little more customary to have the number times the variable on the left. So let's divide by 49/64, divide by 49/64. Anything over itself is 1, so that's 1y. We go off to the side. That is 7/16 divided by 49 over 64. We will do keep, change, and flip. See if I can reduce or bow tie. 7 goes into 7 once. 7 goes into 49 7 times. Now 16 and 64. I know 8 goes into 16 2 times. I know 8 goes into 64 8 times. Oh, those still have a common factor of 2. 2 goes into 2 once. 2 goes into 8 4 times. All right, let's now look and see what we've got left over. 1 times 4 is 4, and 1 times 7 is 7. So y is 4/7. All right, let's look at one more. This looks like it's got some big numbers. Once again, I don't have to, but I would rather rewrite this as 8 over 5 times y is equal to 392. The number times the variable can be on the right, but is typically on the left. Let's divide both sides by 8/5. Those divide out, and I have y is equal to, well, let's go see, 392 divided by 8/5. I know that that is 392 over 1. So it's 392 over 1. That's keep, change, and flip. I don't know, but I'm going to see if 8 goes into 392. So I have 392, and I'm going to try to divide it by 8. 8 goes in, doesn't go into 3, but it goes into 39. Let's see, 4 times. 4 times 8 is 32. Subtract and bring down the next number. 8 goes into 72 9 times. 9 times 8 is 72. So yay, it went in there evenly. 8 went into itself once. 8 went into 392 49 times. Multiply the tops. Well, I need to do that. 39 times 5. 5 times 9 is 45. Carry the 4. 5 times 4 is 20, plus 4 is 24. So I have 245. This is 245 over 1 times 1 is 1. So my answer is 245. So just remember, when you are trying to solve an equation that has a left side, an equal sign, and a right side, if there is something multiplied times the variable, you divide by it, even if it's a fraction. And then you divide the other side by it and go off and do your keep, change, flip. Okay, go do your few problems on solving equations, dividing fractions. Whoops.